Hello everyone. So now, in a complete reversal, I'm not at home in my comfy chair, looking out at the Teams meeting, nor am I sat or stood looking out at people. I'm looking at a camera. So if I'm intensely staring at your eye, I apologise. But thank you very much. Yes, last session of the day. And we're going to be talking about Fabric, specifically the warehouse service, and a bit of technology that I have become very interested in, which is DBT. And this is essentially how I've been getting DBT and Fabric to work together, and some issues that I've found. And in true Microsoft fashion, one of those issues that was a problem 2 days ago is now not longer an issue. So pretend that the issue I show you was an issue. Now it isn't, which is great news for everyone. So my name's Andy Cutler. The QR code is to my link tree. So that'll be my company website, my blog, which is serverlessSQL.com. That's where I blog at the most. My YouTube channel. And I'm also a co-organizer of Data Toboggan. So we have a conference on Saturday, again, free, online, your comfort of your own armchair. We've got 3 tracks during the day. We concentrate on Fabric, Synapse, data engineering, data warehousing, and a bit of Power BI in there as well. Well, thank you. 2 groups of people. So number 1 for Redgate for hosting, and wow, a recording studio and a recording room. So thumbs up for Redgate. And of course, everyone behind Data Left Unattended, which is run by DataGrillen. And I still need to go to a DataGrillen. I haven't been to a DataGrillen yet. So thank you, honestly, and for you for watching. So on the agenda, we're going to set the scene in terms of the service itself. So a little quick look at Fabric, a little quick look at the warehouse service, because it's kind of the crux of what we want to do. We want to build a warehouse. And then we'll look at DBT and why I'm looking at DBT and why I feel paired up with the Fabric warehouse could be quite a powerful combination. A quick look at how it works with the Fabric warehouse. Yes, we're going to look at some SQL. We're going to look at what happens when DBT is talking to Fabric. Some limitations and caveats that I've found whilst doing it. Got a handful of those to go through, and I'll show those in the demo as well, because one of the major aspects of DBT is that it works with different data sources. So it's going to work with Snowflake, it's going to work with Microsoft tools, it's going to work with Databricks, right? So each of those platforms has things that the other doesn't have. So in terms of Fabric itself, so forget DBT, forget warehouses, what's Fabric? If anyone is familiar with Power BI, has used or seen Power BI for building models, for building reports and dashboards, essentially what Microsoft have done is bring the worlds of data warehousing, data engineering, real-time streaming into that familiar Power BI portal. So with another offering called Synapse Analytics, they tried to bring a bit of Power BI into the world of data engineering and warehousing. So this goes the other way around. By the way, it's legally binding if you're doing a session on Fabric to have a Microsoft visual in there, but I've got my own as well. But yeah, so we're adding significant functionality to about Power BI tenant, and that includes being able to run SQL data warehousing workloads, Spark workloads. Of course, we've got Power BI. We've got the power of KQL and real-time streaming, all in a SaaS or software as a service platform. And unlike Synapse Analytics and unlike the other services in Azure, all of the services within Synapse share a common compute engine or a common capacity, right? So you're not having to configure different services and different computes. It's SaaS. You don't have a lot of control over these services. You do with Spark. So we can configure Spark clusters, the size of the Spark clusters, the number of nodes, and we can configure how many nodes that we have and the libraries that we can install on those clusters. So a lot of configuration there. On the warehouse side, there's not much. And the biggest departure in terms of Microsoft data technology is the fact that the storage is underpinned by Delta. So Delta is an open source format to essentially allow transactional workloads between compute and the file format itself, which is Parquet. Highly compressed file format. So basically, what benefit is it, right? So we've got that nice Microsoft visual. What does it do? Well, really, Fabric is an end-to-end data platform solution, right? So I might have all my different sources. That could be on-premises databases. It could be other SaaS vendors, Salesforce, Dynamics, for example. We can have APIs that we want to get data from. And within Fabric, we've got services like pipelines, like data flows, and we can use Spark and code to go and get all that source data, bring it in, land it within Fabric, land it within the storage engines within Fabric. We've got the lakehouse, we've got the warehouse and real-time streaming. We can process that data, we can cleanse that data, use PySpark, Scala, SQL, transform that data and land it, and we can report from it. So we can build semantic models, Power BI data sets, we can build visualizations, reports, deliver those to the business. We can plug in machine learning. So it really is that end-to-end data platform solution. So when you see a Fabric slide and you see all these different engines, really pivot the diagram and just flow and look at the flow of data from left to right. And of course, it's supporting batch and real time, right? So you can bring your batch processing, but bring your real time streaming as well with event streams. Amazing technology that I've just started to use as well. So in terms of the Fabric warehouse service, so yeah, Fabric's software as a service, same obviously for the warehouse service. So it's specifically designed for you to deliver data in a way to store it in a way for analytics and reporting, or your data warehouse, really. So, think star schemas, dimensional modeling. Like we said, there's no configuration, or there's no configuration yet in terms of the service. So unlike a service such as Azure SQL Database or Synapse dedicated SQL pools, we've got no way of sizing the warehouse service. I mean, we can size the Fabric capacity itself, but that's a kind of a superset of the Fabric service itself. But we can bring our knowledge of SQL, we can create tables, views, store procedures. Yes, there are some limitations, and we'll touch on those later on, but it should be familiar to people who are using SQL databases today. And it is a separation of compute and storage in that we have the compute engine itself. It's called the Polaris engine. And we've got the storage. So we've got the Parquet files and we've got that Delta to provide the transactional consistency and a transaction isolation as well. But they are separate. Other engines can come in and read that data. And yeah, so we've got an open storage format. Parquet. I'd honestly love to have been in a meeting room at Microsoft when they decided that we're going to go in on Delta and Parquet as the storage format for the warehouse engine and the default Lakehouse tables as well. Fantastic. And yeah, so we have the concept of ACID. We really only got one transaction isolation level, which is, if you've got a favorite isolation level, it should be this one, which is snapshot. Very optimistic. It basically allows you to do the most reading and writing without conflicts. There's some caveats to that as well. But that's all implemented using that Delta storage technology. So in terms of where the warehouse sits, like, can you use it for anything? It's got specific workloads, but ultimately, you're not going to be building like a line of business application. You're not going to be building, I don't know, a customer bookings system where there's like singleton inserts and SQL selects and singleton row updates and deletes, because it's not for that. The engine's not for that. And the storage format certainly isn't for that. You are building data warehouses in this service. So think dimensionally. I mean, other data warehouse methodologies are available, but in the Fabric data warehouse documentation, it'll have dimensional modeling front and center. And in fact, they have added a series of pages to the warehouse documentation about dimensional modeling. So if you need to brush up a little bit on different types of dimensions and facts, Microsoft have got it in that warehouse documentation itself, which I think is great. And of course, star schema, all the things, Cohen. Where it's sitting in that architecture is gold zone. Now, I know there's been lots of debates over the naming of the medallion architecture and the layers. Look, I'm not going to start discussing the ways and means of the medallion architecture. What I am going to say is the warehouse is going to sit on the gold side or the modeled side. This is the delivery to the business side, because it's going to be modeled. You are going to be taking cleansed data and you are going to be applying your loading processes to turn it into modeled data. For me, that's going to be a dimensional model, dimensions and facts. The other data storage technologies, like the Lakehouse, is going to be used more for the cleansed data and the raw data. Okay, so DBT, the what and the why. So essentially, DBT is transforming data. So it's not responsible for going and getting data from all these different source systems and landing it somewhere. No, doesn't care about that. It's looking to transform data. You tell it, right, here's this data in this database, and this is how I'm going to transform it and land it here. I look at DBT essentially as a framework, because when you're looking at the Fabric Warehouse service, right, Microsoft are giving you a platform. They're not necessarily giving you a process. Yeah, they're giving you a platform in which you can build your own processes. So you can build a warehouse, just a bunch of hard-coded create table scripts. You can use database projects in Azure Data Studio, build your own metadata-driven frameworks, but ultimately you're responsible for building that warehouse. DBT comes in as a way of doing that. That's why I'm particularly interested in it. Ultimately, DBT is really just a compiler. So you're telling it what you want to load and how you want to transform data. It's then compiling it all down into SQL. Even though you're writing SQL, you've got languages such as Ginger involved in DBT. We'll see some of that as we're going through the demo. But ultimately, it's all run on the destination compute itself. So that could be Snowflake, that could be Fabric Warehouses, Databricks. So you're running DBT on a server. You can run it on your own laptop or a container or a server, but ultimately it's using the power of the service you're connecting to itself to run the data loading and processing. And this is what threw me when I started to get hands-on with DBT, is there's a concept of models in DBT. Now, a model is not a whole bunch of stuff, a whole bunch of tables. It's an individual select statement. Manifests itself as either a view or a table in your warehouse. So when DBT is talking about models, they are talking about single select statements, single tables or views in your warehouse. So one of the whys is it's building a dependency tree or a DAG, direct acyclic graph, which is basically you've got a series of things that you want to run. What needs to run before other things can run? So if we think about data warehouses, for example, in what sequence do things have to run for us to load a data warehouse? Well, number one, we've got to go and get that raw data. We've got to land it somewhere. It's not DBT's job, it'll be another process. Then we've got to take that data, cleanse it, possibly enrich it, and load it to a table. So we could load a dimension table, and then we could load another dimension table. Has nothing to do with that original dimension table. We can run it in parallel, no problem at all. We might want to run other loads to other dimension tables that require some data from other dimensions. So that's when we start building a dependency. We can load facts. Usually we have to load facts after we load dimensions. What DBT is doing is when you're writing your select statements and you're loading data from different places, if there are dependencies within that, and you tell DBT those dependencies using a reference function or a ref function, really useful, DBT can build a dependency graph and work out what it can run in parallel and what other things need to be run before other things. You don't need to do anything. You don't need to sequence anything. It'll do that for you. Very powerful. So look, very quick example, which we'll see. So I've got a fact table and I need some data from a couple of dimension tables. I obviously need the raw data itself or the cleansed data that's coming in. And those tables themselves have dependencies. Okay, so this is all out of the box when you start using DBT. We'll be doing this behind the scenes as you're building your loading processes. So we can deal with schema evolution, and it has strategies. Now it's the strategies that we'll see what we can and can't do with Fabric warehouses. Basically, all it means is, excuse me, if we started our warehouse with a certain schema, certain tables, those tables have got certain columns in. Over time, naturally, we're going to want to augment those tables with additional columns. This is one of the reasons why I'm looking at DBT, because it's managing that process for you. So if you tell DBT, if you detect some new columns in this source, I want you to do this with it. And we'll look at some of those options in the demo. But ultimately, you can add columns, you can change your schema, and DBT will deal with that with the relevant platform downstream. Fabric Warehouse, we've got some caveats, which we'll look at. We can also generate documentation. I mean, in the past, I've used Redgate documentation tools. Excellent tools, by the way. Go to the Redgate website, check them out. But yeah, basically, tools that are using metadata that's available to them to generate this documentation. And that's what DBT is doing as well. So it's kind of self-documenting. When you can generate that documentation, you'll have it available for people to, to use. Again, really powerful. So in terms of the flavors, so we've got a couple of flavors of DBT, and we've got DBT Core. So this is the flavor in which it's open source. You can go and get it, download it, install it, you can run it on your laptop, servers, containers, install the libraries that you want to work with. So for example, there will be a DBT Fabric library. There's a Synapse Analytics library. So you're in control of your DBT environment, really, and it's installed on your own compute. But you can use tools like VS Code. I think there's other development environments, there's Atom. And essentially what you can do is author DBT projects using a tool like Visual Studio, because as we'll see in DBT Cloud, DBT has a folder structure, okay? And it's got file types. And we can see that in Visual Studio Code. And yes, so we're installing it. Install it via pip. So on my laptop, I can install it, get it via a Docker, or if you're feeling particularly brave, build the source yourself. However, we do have an alternative, and are going to be using DBT Cloud in the demo. And instead of managing DBT ourselves, we're letting DBT do that for us. Software as a service, right? However, software as a service, as you guessed it, yes, you're going to pay some money dependent on how many users or developers you want accessing DBT, how many of these models or SQL queries that you're running. So it is very much a per seat license that will give you a certain number of runs. Over and above that, you start to pay based on what you use. But of course, with the cloud environment, you've got a full development IDE which you can use to author your projects. You've got the lineage view. It's not available in DBT Core. So that lineage view, where you can see the dependencies of the tables, that's available in DBT Cloud. And the great thing is that for getting started, probably for running a smallish DBT workload, the free developer edition, which I'm using, is really good. It's a little bit like that Databricks Community Edition. Excellent. We can plug into version control. So we can hook up with, for example, GitHub. So I've hooked my project in DBT Cloud up to GitHub. And we can create environments. So we've got development environments, staging environments, production environments. Instead of having to manage that ourselves with DBT Core, we can do it with DBT Cloud. Right, so how do I want to use these two tools together? Fabric Warehouse, DBT. So I want to use the medallion architecture to process my data from raw up until it's modeled and I'm delivering it to the business. So the way that I'm doing that is standard approach. I've got all my source data and I've got pipelines, I've got data flows, I've got maybe some notebooks, querying APIs, and I'm getting all my source data and I'm putting it into a Fabric lakehouse. Now, I haven't split out the zones here in terms of raw, cleansed. My data is available in a lakehouse. I want to use the warehouse service to model my data. I want to use SQL to build my dimensions, build my facts by loading the data from the lakehouse. And that's where DBT comes in. So DBT is going to help me do that and help me orchestrate that loading. So I'm going to select from my cleansed or staging tables in my lakehouse, process it and insert it into my warehouse. So in terms of limitations and caveats that I've encountered as I've gone through using DBT and Fabric warehouses is the very first thing is there is a document called the T-SQL surface area. It basically tells you what is not supported in the Fabric warehouse in terms of SQL commands. And that's really important because if you're running DBT, you plug it into Fabric warehousing and you start to use it and you're getting errors, chances are there's some functionality within DBT that's expecting the warehouse to do something and it can't do it. All right, so I think understanding that T-SQL surface area is really key here. The whole drop and create, and that's not going to be particularly scalable, is really easy to do in DBT. DBT is orchestrating the drop and reload of data. So if you do have a dimensional model that can be built each time it's run, fair enough. It does work well with that. It drops and creates. However, we have strategies to deal with incremental updates and schema evolution that we want to plug into. And that's where some of the caveats of Fabric Warehouse start to come in. Right, so this third one. So when I talk about a model strategy, what I mean is when we're loading, when DBT is generating the SQL to load data, we can tell it to deal with change data in certain ways, what they call strategies. So for example, if my incoming data has a new column, we can tell DBT to either, well, ignore it. Yeah, my downstream models, I've got a set schema, and I don't want new columns to just be automatically added to that. Or we can fail. We've seen something changing. DBT says, I'm not loading it downstream because I've detected something new. The schema's changed, and it will fail building that model. Or we can tell it just to add any new columns. So we can say if any new columns appear, put them in my downstream destination. And we can also tell DBT just to synchronize. So if it sees new columns or if it sees changed columns or dropped columns, it's going to reflect those changes downstream. However, with Fabric warehousing, well, up until 2 days ago, we were not able to alter the table and change any of the columns in the table. So there I am going through my demo, and something that I expect to fail is now working. So hot off the press, Microsoft Fabric warehouses now support altering tables and adding columns. What you can't do is you can't drop columns and you can't modify columns. You can't change a column data type. But it means that one of those model strategies, which is add new columns, works fine, works flawlessly. It will just not do anything with dropped columns from the source. I've had a problem with snapshot models. Now, what snapshot models allow you to do is gives the functionality of slowly changing dimensions, whereas you tell DBT how you want it to check for changed data. So for example, a timestamp. So if you have a last updated timestamp, DBT can use that and it will take care of the retiring of the existing row and the introduction of the new row, all with what you would typically see in a slowly changing dimension metadata, a date from, and a date to. Really powerful, except when I do subsequent runs, it fails. But I've got that with DBT at the moment. It's quite chatty. So when you see the SQL, and we'll have a look at the SQL, it's selecting a lot of metadata, and it's doing a lot of operations such as checking for temporary tables, temporary persisted tables, and the same for views. It's checking for those, it's dropping those. So when you see in the query activity in the warehouse, you'll see a lot of SQL going on there. So that's something to be aware of. Right, let's jump in to the demo. I'll just check the time. So 5:15. So let me open up Fabric. So let's just zoom in a little bit. Okay, right. So I've got a warehouse. And to be honest with you, all I've done to create that warehouse, let's go back into data left unattended, is just create a new warehouse. Giving it a name. There's my blank warehouse. Ready for tables, ready for data. I also have a lake house, and the lake house is where I have my cleansed data that I've loaded by other means. Right? So we're not going to look at those other means. We've got data in that lake house. So I want to load from that lake house into that warehouse. I'll just open that warehouse up. Got a couple of backup tables, ignore those. But essentially, I've got a DBT schema that's already been created. I've got no tables. I've got nothing in here at all. So I'm going to go to DBT. Let me just, here we go. So I'm going to go to DBT Cloud. And let me zoom in a little bit here. And I'm going to go to the Cloud IDE. Let that load. So I've got a couple of different types of tables. So I want to discuss options you have in the warehouse service itself in terms of surrogate keys, right? A very important component of a data warehouse. I want to cover a couple of things that you might want to look at when we're looking at that. So we've got a folder structure. Okay, now these have all been created for me. Okay, we'll largely ignore most of them. I'm going to concentrate on the models and the snapshots, or my slowly changing dimension tables. So if I go to my models, for starters, I've got raw models where what I'm doing is I'm selecting data from my source lakehouse. And in fact, I've got a file, a YAML file, to define my source. Now, I've already pre-configured a connection to the Fabric warehouse. I've needed, obviously, the tenant. I've needed to create a service principal, which gets me a key and a secret. The Fabric warehouse name. And I've added that service principal to the warehouse for authentication. So I've already done that. So my DBT project understands it's connecting to that Fabric warehouse. But I can add a source to another database. And I can add a source to the lakehouse, which is I've done here. So I've given the source a name, raw lakehouse. That's the name of the lakehouse itself, DE LWDBT raw, and then I've added 4 tables. So now DBT can see these 4 tables when I want to load from them. Okay, so we've got products, dates, web telemetry, and web telemetry small, which is what we're going to use here. And in fact, yes, so what you can see down there is, I'll expand that actually, is a dependency, whoops, let me bring that up, for all of the models in my project. Okay, but I've got 2 types. I've got 2 types of dimensions and facts, right? But you can see all of the ways and means that these are connecting together. So just have a look at these raw files, and you'll see what I mean when we talk about select queries or SQL queries. In that I'm defining, can I zoom in on this? I'm defining a select query. Okay, and I'm using DBT's functionality to just reference the source and say, well, my source is that raw lake house, and this is the table that I want to select from. Now, by default, in my DBT project, so if we have a look at the DBT project file, scroll down, this bit of code here, I've told it that when you see a model and a select query, I want you to materialize that downstream as a table. So that's the default. But for my staging views, I don't want those to be persisted. I just want them created as views, so my downstream models can just select from the views. So there's a bit of code, and that config plays multiple roles through DBT in terms of the functionality that you need to add to that model. So I'm telling DBT, look, just materialize this as a view. So when this builds, a view will appear in my warehouse with this definition. So I've done that for dates and products. And look, so if I go in, select from the source, and I'm just selecting columns. So web telemetry, and then web telemetry small. All the same. So then in terms of my star schema, my dimensional model, so what I've done is I've got dates. So what I'm doing with my dates is I'm defining a select query and I'm referencing that model in my raw folder. And this is where the dependencies can be generated because I'm using a reference, and that helps DBT build that lineage. So it understands that my dim date is coming from my STG dates model, so it can build, and as we see there, it can build a DAG for that, and that STG dates, staging dates, pulls from the lake house. We've got that for the products and for the fact table. With the fact table, I've added an additional configuration to the model because I want to incrementally load the data. I do not want DBT to drop my fact table and recreate it again because, well, multiple things. Number one, fact tables can grow quite large. We don't want it to be deleted and have to be rebuilt again. Number two, the source that we're using to load may be an incremental source itself. We might not have the data to do a full load in our data loading process. We probably have a process in which we can do a full load if we want, but in this instance, with a fact table, we really don't want to have to drop and recreate it. So I'm telling it, look, it's an incremental load. And if I scroll down, there you go, I've got that ref command. So that helps DBT build that dependency. And then I've got some cool code to basically say, well, is this model an incremental model? Well, yes, I've defined that in the configuration. It will add my incremental loading logic in there. So for example, I'm just selecting the maximum date time in the table. I will use that to define the data that I'm loading from my source tables. And I can select that data as well. So what I'll do is I'm going to run this model. So we're going to do DBT run. Let me just pull this up. So DBT run, and I'm going to go select, and I will say I'm going to load my, let's just bring that down. I'm going to load my raw.start, and I'm going to load my star schema /demo01. I think I can just do without the start. Okay. So let's run that. And hopefully there's no problems with any of the network connectivity. Okay, so, well, it's built our views. I was expecting it to build, oh, hang on, is it a backslash? Let's try that again. Run those system logs. Okay, that's built it, but it's not selected. So all I'm going to do is I'm just going to get rid of that raw, select demo 01. Maybe there's a problem with the syntax there. Scheme. Let me just have a quick look. Remember my it's a dot, not a slash. It's so used to slashes. I'll do that all again. Right, so I can pick and choose what folders I want to load, right? Because I could have some models that load before other models. Full control. So for my DBT project, it's materialized my staging dates, products, my web telemetry and web telemetry small as views in my warehouse. Dim date, fact web telemetry, and dim product are actually materialized in the warehouse based on my select queries. So let's just have a little look at that. If I switch back over to here. Oh, look, there we go. We've got dim date. Well, let me show that. We've got dim date. So we've got data in there because what DBT is doing, it's compiling that SQL within those models and then running them. We've got product and we've got web telemetry. Now, I won't go into too much detail on this, but I am using a utility function within DBT to generate a hash that I'm using as a surrogate key. I also have an alternate model, or alternate models, in which I'm using row numbers to generate integers, which I can then use as my surrogate keys. We'll leave that discussion for another day. Suffice to say that if you're using hashing, then DBT can parallelize dimensions and fact loads. We're using, and unfortunately, at the moment in Fabric warehouses, we don't have any auto increment, we don't have any sequence. So we're kind of stuck with using a workaround like row number. So we can use row number to generate those integers, but we have to load our dimensions first before we can load our facts and look up those keys. We just have a little look as well in the views, so you'll be able to see those views down here. Stage dates, products, web telemetry small. Okay, great, fine. Build my model, build reports. Fantastic. I've got a snapshot dimension, i.e. a dimension that I want to track the changes over time. In my snapshots folder, I've created another folder called star schema, and I've got my event types. And my configuration, as you can see, is a little bit more comprehensive, right? So I'm telling it, well, where do I want to store this snapshot? What's the unique key, i.e. in the world of a dimension, the business key. What's the business key that I need to use to work with the changing of data, and the retiring of rows and inserting new rows? I have a last updated column in my source, so I can use the timestamp functionality. However, if I didn't have that, I could essentially use a check all columns strategy. It's less efficient, but it's almost like using a hash of all the columns to check if anything's changed. Essentially, what that means is I can have my select statement for my dimension, and all I've done is I've just hard coded my event types because I've only got 3 event types. But of course, this could come from a source system. And I've got a last updated column, and that's how I'm going to get this last updated to work with my snapshot. And then I've got a final select. So what I'll do is I'll just run my snapshots. So I'll run snapshots, and that's going to populate or create that table with, and we'll have a look at the attributes. If we go into my Synapse warehouse, to refresh that. There we go, dim event type. So let's have a look at that table. Right, so we've got the hash that I've created. We've got our business key, the event type, and the event type description, and the last updated columns. They're all from the source data sets. No problem here. Now we've got the DBT metadata, right? So anyone that's familiar with building dimensions knows about the valid from and the valid to. These should be contiguous for a business key, i.e. showing the flow of the business key changes over time. So at the moment, we've got a valid from and a valid to. Now, those valid froms and valid tos are actually generated from my timestamp column itself. So the granularity is just the day at the moment. Oh, I could have a time in there as well, but you probably will. However, when I go back to DBT, and I'm just going to change one of these, I'm going to say browse the product, and I'm going to initiate a change. I'm going to mimic the last updated. And at the moment, and I've sent this back to DBT, is I can't get that snapshot to, ooh, hello. Hello. Let's have a look. No problem. There we go. It works. Fantastic. Right. So there we go. So if I, that browse product, so we had the original record, browse the product. We changed it to browse product. There's my last updated, and DBT has retired the old row and adding the new row. Oh, I'm chuffed with that. I might have typed something incorrect last week or the week before. So there we go. If I go back to my DBT environment, I've got a couple of minutes left. My demo 2 really is exactly the same, but I'm using row number. Okay, so we can build that. So what I'm going to do is I will run the DBT, DBT run. We don't need to run the raw models because they're already done. So we can run star schema.demo02. Got to select my model. And again, it'll take a few seconds to run. After this, we'll just have a look at some of the SQL that DBT is generating, because it's very interesting, especially when you're using a service like Fabric Warehouse, Databricks, Snowflake, whatever. You kind of need to know what these tools are generating under the hood. I'm sure we've all been there where we've used tools that are just generating SQL. Sometimes the SQL isn't great, but there we go. So I've deployed my other tables where I'm using I go to the product, where I'm using the row number to process. However, this time DBT is having to run the 2 dimensions before the fact, because if we have a look at the dependency for that fact table, it obviously depends on its source table to get its data from, but it does depend on the product and the event, because I'm looking up my surrogate keys using my dimension tables. With my hash, I don't have to do that because I'm going to be hashing on the same data that my dimension is hashed from. Again, I'll leave that up to you to decide. So in terms of the SQL it's generated, okay, great, it's doing all this stuff and we can just magically see results and tables appear. So I've just pulled out, and it's the last thing we'll look at, I've pulled out a couple of queries that it's running. So if we have a little look, and I will show the views. So what is it doing when it's just created a view? Right. Well, firstly, it's got some metadata. It's doing a select and getting some metadata about what is and isn't already there. Right. So this is all DBT doing this. Right. It drops backup views. So it's got an exec and it wraps SQL, or it wraps a lot of the generation of the views and tables in an exec command. We're then creating the view. So exec create view stg dates. So we'll scroll all the way down. Doing some more metadata operations. So let's just select it from there. We should see. Okay, not sure why nothing's coming back there. Because it's the staging view. And then just drops the staging view as well, because it's the very first time that it runs, it doesn't have to drop any backups. Subsequent runs, when the object exists, DBT will back up the object before deploying the new version of the object. If we look at table, so if we have a look at the table here, I've chopped the metadata out. So all of the selects from the system views and system tables I've removed. So essentially, if the destination table doesn't exist, what it's going to do is, well, it's going to drop a backup table if it exists. It's just a bit of a belts and braces. And also the temp view that selects. It's then going to create a temporary view over the source data. Then it's going to create the destination table by selecting from that view. So there's a couple of hops that it's doing. So for example, if we scroll down here, I think you can probably see this. If a backup table for event type exists, and this is the event type load, just drop it. If a table already exists, rename it, and the renaming is what turns it into a backup table. Then it's got this view, or this temporary view, which then allows it to select the data. So it's almost providing a view as a layer automatically. And there's my SQL query. So you can see that's what I've defined in my DBT model. And then I'm going to create a table. So create a table, dim event type, as selecting from that temporary view, which is the source data itself. And then it does some checks to drop these objects afterwards. So well worth having a look and seeing, well, what's the SQL that's being generated behind the scenes? It's helped me troubleshoot what is and isn't working. So the last thing I want to do is show the schema enhancement. So if we go back into DBT, I promise it will be the last thing that I do, is let's have a look at my web telemetry. Now I've specified that it's incremental and to sync all the columns. Now with a Fabric warehouse, that's not really going to work and it's not a good idea. So actually, I want to append new columns. So if any new columns are detected in the source, they're going to be automatically added to my downstream. And in here, within my select statement, I do actually have just another metric that I've created. Just for demo purposes, it's just a recreation of the normal event count, another event count. But in my select statement, I haven't referenced that column. So now, hey, we've got a new column in our fact table. So what I will do is I will jump into my notebook very quickly. And I'm just going to add some new data or some more data to that fact table. Right, so let's have a look, and I'm just going to go and just load the 7th of February. So the Spark session is going to be instantaneous, good, because I'm using the starter pools, and should be a few seconds. So really all this lakehouse is, it's just my cleansed data that I've loaded in from somewhere else. Should be a few seconds running that. And then what I'll do is I'll just append it to the table that DBT is referencing in my DBT sources. So should take a few seconds to run. And then we'll go back to DBT. There we go, command executed. We'll go back to DBT and we'll just run that one model. Okay, so we're just going to select my fact web telemetry. Need to save it. There we go, and then run it. Now, all being good, that is incremental logic within the model or the select query is going to see that it's an incremental table. My incremental logic is going to fire. It's going to see that there's new data in my source, bring it into my fact with the new column. So it succeeded. So we'll have a look at the warehouse and scroll up, and in our fact web telemetry table, I scroll across, we can see another event count has been added. However, let's say that, well, we now need to remove something from the source, or something from the source has been removed. So what I'm going to do is I'm just going to change this, but what I'll do is I'm going to load some more data in. Just going to run that. And here we go, I'll just load that very quickly. And in DBT, I'm now going to change it to sync all columns. And I'm going to remove, let's say, user ID. I don't need it anymore. All my data needs to be anonymous. I'm going to remove that. Let's go back to my notebook. Whoops. Just wait for that to finish loading. So while that's running, I'll make the slide deck available because it's got a bunch of links to the DBT documentation, blog posts, people's other explorations of DBT, the Slack channel, the DBT Slack channel, brilliant. Fully recommended if you want to crack on with DBT. Okay, so we loaded the data. We'll go back to DBT and I'll run the model again, hoping and thinking that the downstream column is going to be dropped from the warehouse because, well, I don't need it anymore. However, boy, if this works, I've got a couple of people to speak to, but it's failed. Now, if we have a quick look, the last thing we do is I'm just going to look at the telemetry. So basically in this telemetry, I can see what it's running. Usually, if there's an error, we scroll all the way to the bottom and we can see that the specified alter table statement is not supported in this edition of SQL Server, and that's because it's issuing an alter table drop column, which isn't supported. So some things are going to be supported, some things aren't. So for example, I have had success with ignore, well, with fail. So ignore basically just ignores anything that's changed downstream. Append new columns works because it's just adding new columns, because alter table add column works in the warehouse, but I can't synchronize. I cannot synchronize my source with my destination. So I'm going to flick back to my slide deck, and here are the links. I'm going to make them available on the PDF, and thank you for listening. I didn't hear any questions coming through. I wasn't interrupted, but my lovely hosts are just about to walk in, so